Okay, so for this one here, 4 gallons into cubic inches. What's our conversion between gallons and cubic inches? 1 gallon is approximately 231 cubic inches. So the gallons cancel out. 4 times 231 is 924. 7 quarts into cups. How many of you got 28? Okay, good. So we got quarts. I don't know a direct conversion from quarts to cups, but I can go from quarts to pints. 1 quart is 2 pints. Canceling out the quarts. And then 1 pint is 2 cups. Canceling out the pints. 7 times 2 times 2 is 28. 2,700 cubic centimeters is how many milliliters? $2,700. Remember, a milliliter is defined to be a cubic centimeter. So they're the same thing. A cubic centimeter and a milliliter are exactly the same. What's that? 0.08 liters is how many milliliters? On the chart, from liters to milliliters is 3 spots to the right. So decimal point goes 1, 2, 3 spots to the right. That's 80 milliliters. Fluid ounces into pints. Again, I don't have a direct conversion from fluid ounces into pints. But I do know that 1 cup is 8 fluid ounces. And that takes 2 cups to make a pint. So the fluid ounces cancel out, the cups cancel out, and we will be in pints. 64 divided by 8 is 8, divided by 2 is 4. There are 4 pints and 64 fluid ounces. How many of you had all 5 of those right? How many had all of them except for the cubic centimeters to milliliters? Okay. Any major questions on those? If you remember that cubic centimeters to milliliters, we did an example yesterday of like a car engine. Let's say you have a 6-cylinder car engine. And let's say that this is a 6 centimeter stroke, 82 square centimeter area of the piston head. We talked about that displacement is going to be a volume, and that volume is going to be the area of 82 square centimeters times that distance, that height of 6 centimeters, which is going to be 492 cubic centimeters. If that's a 6-cylinder car, what's that multiply out to be? What? Come on. What is that? 2,952, something like that? Centimeters cubed. So that 2,952 centimeters cubed is how many milliliters? Remember, a centimeter cubed and a milliliter are the same thing. So 2,952 centimeters cubed is 2,952 milliliters. Now, to convert that into liters, I have to move on the chart. It's liters, deciliters, centiliters, and milliliters. So that's 3 spots to the right. Move my decimal point, or from milliliters to liters is 3 spots to the left, I should say. My decimal point has to move 3 spots to the left. So this is 2.95 liters. Any questions? Okay. Well, for today then, we're going to move on to the next type of measurement that we're going to deal with, and that is weight. Before we get too far into it, though, I want to discuss the difference between weight and mass. We tend to use weight and mass interchangeably. They are not. There is a difference. Mass is the amount of matter in an object. The mass of an object will be the same whether it's on the Earth, on the Moon, on Mars, on Jupiter, wherever you go. It has the same amount of material in that object. Weight is the measurement of the force of gravity on the object. Now, the force of gravity does vary slightly on Earth from one point to another. It is its smallest at the equator. It is at its largest at the North and South poles. But it's close enough to the same that we can consider it to be constant. Like I said, very slight differences. So the weight of an object on Earth is pretty much always the same no matter where you're at on Earth. The mass of an object, of course, never changes unless you actually remove part of the object. So what we normally do is we consider the mass and the weight to be interchangeable. Just because there's a direct conversion between them. So if we measure the weight, we just assume that the mass is proportional to it. The way that weight is measured is we usually take some sort of a spring that has a known ability to stretch. It takes a known amount of force to stretch it a certain distance. And we put it on a scale with some sort of an indicator on it. And then we hang whatever it is we're trying to weigh on that, and the amount it stretches, that indicator goes up and down on a numbered scale here. Whatever number it lines up with is the weight. We measure how far that object stretches the spring. Mass is measured on a balance. So we take an object with a known, or we take the object we're trying to measure, put it on one side, and we take an object with a known mass, set it on the other side until they balance. So we might add smaller ones here to balance it out. Exactly. Until they balance. Then we take whatever these masses are, add them up, and that is the mass of this object. Like we said, mass is constant. If I take this to the moon, well, the force of gravity on the moon is less than it is on Earth. So the amount that gravity pulls on our object is going to change, but the amount that gravity pulls on the known masses is also going to change. So the same mass is still going to balance our objects. The mass will not change. However, on the moon, since the force of gravity is less, the spring is going to stretch less, and the weight is going to be much less on the moon because there's less gravity. So weight is a measure of force, and it depends on the amount of gravity. Mass is compared to known masses, and it does not depend on gravity. So when we're talking about weight in the standard system, we are truly talking about weight. So our big unit of weight that we use in the standard system is a ton. How much is a ton? Of course, our next unit would be a pound. How many pounds are in a ton? 2,000 pounds. This is actually what we call a net or a short ton. 99.99% of the time when you hear the word ton, they're talking about 2,000 pounds. But there is also something called a gross or a long ton, which is 2,240 pounds. The difference? Well, if you think of your paycheck, your gross paycheck, if you work 30 hours in a week and you're getting paid $9 an hour, your gross pay is just 30 times 9 or $270. But you don't have to work for very long before you realize you don't get $270. They take out taxes and all sorts of other junk, and you might get $190. What you actually get is your net pay. Same thing here. The ton was originally used for measuring grain, for trading grain. Well, you can't just put a ton of grain on a scale. It's going to fall, it's going to run off the edges. So it had to be in a container. The container that held about a ton of grain was about 240 pounds. So the gross ton was the grain with its container, and the net ton was just the grain. Like I said, 99.99% of the time when you hear the word ton, we're talking 2,000 pounds. I don't think I'll ever do anything in here where I ask for the long or the gross ton, so we can just always assume it's 2,000 pounds. But I just wanted you to be aware that there is a variation out there. There's also something called a gross, which is very different. A gross is a dozen or 144. So smaller than a ton, we have the pound. The abbreviation for pound is LB. I usually underline it so you don't mistake that first L for a 1. It would make sense for the abbreviation for pound to be PD. But in the bookkeeping for buying and selling grain, PD was already used as the abbreviation for paid. So they use LB, which comes from the Latin word for pound, which is libra, and that's what they use for the abbreviation for pound. Smaller than a pound, we have ounces. How many ounces are in a pound? 16. Very good. There is a unit in between there called a stone. A stone is approximately 14 pounds. There's also a hundredweight, which is actually still used in dairy quite a bit. Your price for milk is per hundredweight. A hundredweight is just 100 pounds. There is a unit smaller than an ounce. By the way, the abbreviation for ounce is OZ. Since they use the Latin word for pound, they also use the Latin word for ounce, and I can't remember what it is right now, but so that gives us OZ as the abbreviation for ounce. Smaller than an ounce, we have a dram. There are 16 drams in an ounce. A dram is an apothecary unit. Usually for medications, they would prescribe maybe an 1/8 of a dram or a 1/16 of a dram of a medication for you, or a 1/4 of a dram if you're in really rough shape. So it's used for measuring medications. Now don't confuse that with gram. Gram is metric. Dram is a standard unit. So the D. Also for medications, there was a grain. There are 7,000 grains in 1 pound. Now this is not grains as far as like a piece of oats or corn or anything like that. This is grains as far as in like salt, grains of salt. Those of you that do any of your own reloading for gunpowder, grains is often used for gunpowder, anywhere from 80 to 150, 180 grains, depending on what you're loading, is the amount of gunpowder you'd put in. 7,000 grains is 1 pound. So 100 grains would be a 70th of a pound. Or if you convert it with 16 ounces, what does that come out to be? I don't know, somewhere around 70 divided by 16 is about 1/4 of an ounce, 1/4 or 1/5 of an ounce. Okay. Something you hear a lot about these days is gold and silver. You hear advertisements on TV all the time, buy gold and silver and stuff like that. Precious metals are bought and sold not in ounces and pounds, but troy ounces and troy pounds. We had mentioned when we did our length that the standard system was not standard worldwide. That throughout history, different world leaders had declared that their thumb and their foot and their arm was going to be the official inch and foot and yard that was used. And therefore, from one country to another, a yard and a foot may be slightly different. The meter, as we said, was based off the Swiss yard, which is slightly longer than the US yard. The same happened with weight. Ounces, pounds, and tons were different from one place to another. Precious metals, the center around the year, 100 BC to 200 to 300 AD for trading precious metals was the island of Troy in the Mediterranean Sea. So we still use troy ounces and troy pounds for precious metals. 1 troy pound is only about 0.82 standard pounds. So it's quite a bit smaller than a standard pound. 1 troy pound, though, only contains 12 troy ounces. So even though a troy pound is considerably smaller than a standard pound, a troy ounce is actually larger than a standard ounce. So when they say that gold is like $1,800 an ounce, that's not a standard ounce, that's a troy ounce, which is slightly larger. I will never make you do those conversions, but just so you know that they are out there. In this, you said these are units of weight. In the standard system, there is a unit of mass. You don't have to put this in your notes. I will not test you on this either. It's called a slug. Yes, a slug. 1 slug is 32 pounds. Yeah, interesting unit, huh? Okay, so on to the metric system. In the standard system, we tend to focus on weight using the pounds and ounces. In the metric system, they tend to focus on mass. Mass changes less. So mass in the metric system is measured in grams, is the standard unit. A gram is about the mass of a large paper clip. It was defined to be the mass of 1 milliliter of water. So the milliliter is defined to be a cubic centimeter. So we have that connection between length and capacity. A gram is defined to be the mass of 1 milliliter of water. So we now also have that link between capacity and mass. And of course, gram is abbreviated with a G. Smaller than a gram, we have a decigram, a centigram, and a milligram. Then skipping a couple spots, we have the microgram. Again, in the medical field, you'd see that mcg instead of the μg. Larger than a gram, we have a decagram, a hectogram, and a kilogram. And if we keep going, bigger than a kilogram, we have megagram, which is 1,000,000 grams. Because of the need to translate between standard units and metric units, they have taken a megagram, which is 1,000 kilograms, and they've used it as what they call a metric ton. Now, a kilogram is slightly more than 2.2 pounds, like 2.208 pounds. So 1,000 kilograms is about 2,200 pounds. So it's a little bit bigger than our net ton or short ton, a little bit smaller than the long ton, but it's in the same order. So since that's what we're comfortable trading in standard units, they created that unit in the metric system just to fit in a little bit. And as we mentioned with our other units, the standard unit, the gram, of course, gets used a lot. Kilo gets used a lot, so kilograms get used a lot, and milligrams get used a lot. And of course, micro gets used in the medical fields for measuring medications and stuff. But the centigrams, decigrams, decagrams, hectograms really don't get used much. There's actually been discussion of eliminating them from the metric system, but they're there, so why get rid of them? And there are a few specialized applications. Like we talked about the deciliter getting used in medicine for doing blood testing and stuff. There are a few specialized applications where those other units are used, and rather than eliminating those and having to rewrite whatever instructions come for those, they'll just leave them in there. So doing conversions. Well, with the metric, it's just like any other. If we have 0.074 kilograms, and I want to convert that into grams, that's 3 spots to the right. Come on, 3 spots to the right on the chart. So decimal point goes 3 spots to the right. That is 74 grams. If I have 2,900 milligrams and I want to convert it into grams, milligrams to grams is 3 spots to the left on the chart. So my decimal point goes 3 spots to the left. That is 2.9 grams. A common conversion is 480 micrograms going into milligrams. That is 3 spots to the left on the chart. Decimal point goes 3 spots to the left. So that would be 0.48 milligrams. If we're talking about water, and I have a container, again, we're going with a box-shaped container just to make it easier on ourselves. Let's say this container is 8 centimeters by 12 centimeters by 10 centimeters. And it's filled with water, and I want to know what's the mass of the water that it contains. Well, first thing I can do is I can find its volume, which is going to be the area of the base, 8 centimeters times 12 centimeters, times the height of 10 centimeters, which is going to give me 960 cubic centimeters. I can convert that into capacity. 960 cubic centimeters is going to be how many milliliters? Not everybody at once. 960. A cubic centimeter and a milliliter are the same thing. 960 milliliters of water, remember, is going to be how many grams? A gram is defined to be the mass of a milliliter of water. So 960 milliliters of water is 960 grams. Any questions so far? Okay, so in our standard units, if I have 7 pounds, how many ounces is that going to be? How do I make that conversion? Units getting bigger or smaller? From pounds to ounces, the units are getting smaller, right? So the number has to get larger. So I'm going to multiply. What's the conversion between pounds and ounces? 16. So 7 times 16 is 112. If you're absolutely stumped, of course, we can always do out the formal conversion. 7 pounds over 1 times pounds on bottom, ounces on top. 1 pound is 16 ounces. And you see the pounds cross cancel, and it is 7 times 16 ounces is 112 ounces. What if I have something that is 7 ounces and I want to convert it into troy ounces? This isn't something I'd make you do on a quiz, by the way, but I just want to see how you are doing with these conversions. Well, first thing we would have to do is we don't have a conversion that we've talked about that goes from ounces to troy ounces, but we do have from pounds to troy pounds. So I would take my 7 ounces and I would convert it into pounds. 1 pound is 16 ounces. So my ounces will cross cancel here. I've got 7 pounds over 16. 7 divided by 16 is 4375, I believe, pounds. So now I need to convert that 0.4375 pounds into troy pounds. So pounds on top or on bottom, so they cross cancel. Troy pounds on top. 1 troy pound is about 0.82 regular pounds. So the pounds cross cancel. I have 0.4375 troy pounds over 0.82. So I've got to divide that. 0.4375 divided by 0.82. 0.5335 troy pounds. And of course, a troy pound, so 0.5335 troy pounds, one troy pound is 12 troy ounces. So the troy pounds cross cancel. I'm going to take the 0.5335. Now I'm going to leave it in my calculator. Multiply by 12. Gives me 6.402 troy ounces. So 7 standard ounces is about 6.4 troy ounces. Now again, I'm not going to make you use troy units, but I just wanted to make sure you saw, here's a case where about the only way you can do it is those conversion factors. So it's nice to see them in practice. Something I want you to try in your notes, just to see how you're doing. Okay, so this box is 40 centimeters by 30 centimeters by 120 millimeters. If that is a rectangular tank filled with water, how many kilograms of water are in that tank? See if you can figure that out in your notes quick. So our first step here is to find the volume. But we have centimeters, centimeters, and millimeters. So first I got to change the millimeters into centimeters. That's going to be 12 centimeters. So my volume with the area of my base, the 40 centimeters times the 30 centimeters, times the 12 centimeters of height. So that is 1,200 times 12 is 14,400 centimeters cubed. That's our volume. So we need to change that into a capacity. 14,400 centimeters cubed is, of course, 14,400 milliliters, which, of course, is 14,400 grams of water. So now we have to do the conversion into kilograms. From grams to kilograms is 3 spots to the left. So that contains 14.4 kilograms of water. In your packet, page 238, 51 through 56, and page 266 in that packet, 49 through 54. By the way, in the metric system, there is a unit of weight. The unit of weight in the metric system is the Newton. If you had chemistry or physics, you probably heard of a Newton. May not have heard of the slug. 1 kilogram of mass has a weight of 9.8 newtons. Now, we're not going to deal with newtons, but just so you know, they're out there. So there is a unit of weight. We tend, by the way, to talk, when we're talking about people, when we're talking about weighing people, you know, we might talk about someone weighing 110 pounds, but when we convert it to metric, we still use kilograms for some reason. Even though it's a unit of mass, we would say they weigh 50 kilograms. 50 kilograms is approximately 110 pounds. But that 50 kilogram person really would weigh 490 newtons. Well, you would weigh way more than 490 newtons.
I only weigh like 120 pounds.
Yeah, so you'd weigh like 510 newtons.
Wow.
Okay, so there's your homework. I'll let you guys have the last 14 minutes here to work on it.